Hello, everyone. In this lesson, we will learn about the implementation of parking space control using S7-1200 PLC. With the rapid urbanization and growth of the automotive industry, the number of vehicles has increased significantly, leading to pressing parking management issues. In recent years, parking management technology in our country has continuously improved, with intelligent parking management systems gradually replacing traditional ones. These systems utilize automated devices and technologies to facilitate quick vehicle entry and exit, automated billing, and significantly enhance the efficiency of parking lot usage. Moreover, through networking and information technology, they enable real-time transmission and management of parking space information, thus improving overall parking management efficiency. So, how can we design a simple intelligent parking control system using PLC? Let's first look at the specific task requirements. A certain underground parking lot has 100 spaces, with proximity switches at both the entrance and exit to detect vehicle entry and exit. If the parking lot is not full, a green indicator light at the entrance will illuminate, indicating available spaces. The entrance barrier can then be raised to allow vehicles to enter. The barrier will automatically reset after a 10-second delay. If the parking lot is full, a red indicator light will illuminate at the entrance, indicating that no spaces are available, and the entrance barrier will remain down. When vehicles exit, the exit barrier will be raised to allow vehicle departure, followed by an automatic reset after 10 seconds. As shown in Figure 7.2.1, please design the parking space control system. Next, we will implement the task by determining the I/O address assignment table based on the parking space control requirements. The table already has assigned input and output addresses. The system start corresponds to I0.0, the stop corresponds to I0.1, the vehicle detection proximity switches at the entrance and exit correspond to I0.2 and I0.3, respectively. The entrance door open command corresponds to Q0.0, the exit door open command corresponds to Q0.1, the green indicator light, indicating available parking spaces, corresponds to Q0.2, and the red indicator light, indicating full parking, corresponds to Q0.3. Figure 7.2.2 shows the PLC peripheral interface wiring diagram. In the diagram, the system start/stop buttons SB1 and SB2, as well as the entrance and exit vehicle detection proximity switches SQ1 and SQ2, and the parking lot's red and green indicator lights, can all connect directly to the PLC. The raising and lowering of the barriers is controlled by a motor, requiring indirect connection through intermediate relays. After completing the relevant peripheral wiring, we will design and write the control ladder diagram based on the control requirements and the I/O assignment table. Let's understand the program design approach. Program Segment 1 handles the start and stop control of the parking system and the display of the red and green indicator lights. When the start button I0.0 is pressed, the system will start and remain active until the stop button I0.1 is pressed, at which point the system will stop. When the system is active and the number of parked vehicles is less than 100, the green indicator light will illuminate, indicating that the parking lot is not full. When the number of parked vehicles reaches 100, the red indicator light will illuminate, indicating that the parking lot is full. Program Segment 2 uses an count up and down counter to detect and count vehicle entries and exits. When the parking lot is not full and a vehicle is detected entering at the entrance, the CU input activates, incrementing the counter by 1. Once the vehicle count reaches 100, the counter's QU output will be 1, indicating that the parking lot is full, and the red indicator light will illuminate, preventing the entrance barrier from raising, even if vehicles are detected. When a vehicle is detected exiting at the exit, the CD input activates, decrementing the counter by 1. Program Segment 3 controls the opening and closing of the entrance and exit barriers. When the green indicator light is illuminated, indicating the parking lot is not full, and a vehicle is detected entering, the entrance barrier will be raised, and after a 10-second delay, it will automatically lower. When the red indicator light is illuminated, indicating the parking lot is full, the green indicator light will turn off, preventing the entrance barrier from raising, even if vehicles are detected. When a vehicle is detected exiting, the exit barrier will raise, and after a 10-second delay, it will automatically lower. We will use the Totally Integrated Automation (TIA) portal to create the project, program, and perform online debugging. You should create the project, define PLC variables, and complete the programming and downloading processes on your own. Once the program has been downloaded, we will proceed to debug and monitor its operation. Start the CPU. Enable monitoring. And open the simulator. Press the Start button I0.0, the parking control system will activate, showing that the current vehicle count is 0. And the green indicator light Q0.2 is on, indicating that parking is available. When a vehicle is detected at the entrance, the counter will increment by 1, Q0.0 will activate to open the entrance door, and the timer will start. After 10 seconds, Q0.0 will deactivate, and the entrance barrier will automatically lower. When a vehicle is detected exiting at the exit, the counter will decrement by 1, Q0.1 will activate to open the exit door, and the timer will start. After 10 seconds, Q0.1 will deactivate, and the exit barrier will automatically lower. Since there are many parking spaces, to facilitate monitoring when the parking lot is full, we will press the load input I0.4 to set the counter's current value to 100. At this point, the red indicator light Q0.3 will illuminate, indicating that the parking lot is full, and the entrance barrier will not raise, even if vehicles are detected. This concludes the monitoring process using counter instructions for parking space control. That concludes this lesson. See you next time.